module which we are going to understand here is IO operations. This is the fundamental operations when we are talking about the systems and when we are going to develop the applications in the Linux systems. So before going to the deep dive into this section, we can just I will want to make some clarification. Most of this course is based on this book, which is written by the Michael Carricks. Name of the book is The Linux Programming Interface, and this book will be kind of a guide for us for this entire course. So if anyone wants to refer anything, you can go and purchase this book and refer it. So I'm also skipping few part of this book, which is initial part, which I'm thinking you already know. Anyone who is interested and who is not following, we should go and look at that initial part of from the book, and we are directly jumping to the core, or we are jumping to the directly to the programming part of the book. There are some prerequisites, some fundamental concepts you need to know. Of course, you need to know C in quite a well, and also some fundamental concept about the Linux and Unix systems. So if you're not aware of that, go back to the book, read that thing, and then come back. So in our operations, we will be starting to learn about a few system calls. And when I say system calls, they are this pretty much everything happening on your system are just based on these system calls. So whenever you open a file, whenever you create a file, whenever you do anything on your system, you basically make the system calls to the kernel. So the whenever a process, let's say a process A, and is spawning to the another process, let's say process B, when we say the process A has spawned the process B, it's technically incorrect statement, because process cannot spawn any process cannot interact with the other process by its own, process cannot uh, terminate itself, or not neither a process can create itself or other processes. What process can a process do? It makes system calls to the kernel, and they are through the APIs defined. And whenever the API call or system call is reached to the kernel perform the operation on behalf of the call, on the response of that particular call. So in our case, if process A wants to create a process B, it will use the system call called as fork, and kernel will interpret the call and say, oh yes, it's a call for creating the new child process, and here is a child process for you. So in general terms, we say the process A has spawned the process B, but actually there is an intermediator, the kernel in between them, in this entire operation. That is a little introduction to the system calls. So in IO operations, we will be looking to the 4 system calls, out of which one is open, then read, then write, and finally close. Quite self-explanatory. We are going to write a program, and then it will be more clear to you. One of the concepts that we are going to understand is the universality of these IO operations. So you might be aware of the phrase in Linux that everything in Linux is a file. So when we talk about the file, when we are doing the IO operations on a file, a general file, like your text file or your whatever file you know as in sense of the file in general terms, those all operation can be performed on other kind of files too. So in Linux, your general file text file is also a file, your pipe is also a file, your socket is also a file, and your device is also a file. So this is how this universality work. We will be looking at one quick demo of this universality, which will make the things more clear to you. We will also look the error handling. And I would like to touch on this topic just to emphasize on why it is important and how error handling can help you when you're writing a code, especially when you're writing the big program. Uh, the lots of debugging time can be reduced by simply introducing the error handling block. File descriptors. These are the descriptors given to the file by in defined in the POSIX, where you have the 0, 1, and 2. 0 corresponds to input, 1 for output, and 2 for an error. We will be discussing them more. And at the end, we will be looking at, we will be writing in today's video, we will be writing these all programs to, uh, we will start with no error handling. Then we will look uh, how the program behaves when we do not have the error handle into the program, and when we introduce the error handle, how we can correct that buggy program. Then we will do the open system call. Then we will look at the read system for call and write system call. So these are the files which I have created for you. All are the empty files now. We will be writing them together. So stay tuned. We will be meeting in Linux. Okay, so we are here. Sorry for this. Here we have all the files, and you can see all of these files are 0 byte. So we will be writing the code for one by one for all the files. We will start with IOPS error, IOPS no error handle, and I will be using Vim for it. Oops, no error handle.c. So here basically we will be writing the code to open a file, and this program will be not opening that file because of something that we will be handle in next program. So let's call our headers file control.h, and we will be in the stat.h, and for the I operations, standard io.h. I'll be writing a function which returns nothing, and let's say it's a file create function. Write create function, and which will take the name of the file. Let's say the file name, and let me do something for more uh, more easiness if I want to jump between the lines. Okay, and insert. I will be we will be calling the function open, and the first parameter which the open function takes is the file name. So we will be writing the file name directly. The second parameter it takes is the uh, modes or flags by which the operation which we need to perform on the file. We will say read write, and that's it. This is our little tiny function which supposed to be open a file. And let's write our main program. I will not take arguments. I will just be writing a simple programs to make it easy for now, and also the reduced time. So I'll call this this function, file create, and I will give name to the file. Let's say file no error handle.txt, and conclude it and return 0, and that's it. This is the program. We'll be writing it, and let's go to the terminal and let's compile this program. IO ops no error handle, and let us give the name no error handle, and okay, that's the bad thing. Edit, it's the escape line number 2, and escape w, and our program is successfully executed. Let's say the our program is executed, and there is the or executable file no error underscore handle. Let's run this file. Now you can see this program should uh, open a file. That's our intent. But if you notice, this file do not exist. So this file, if you this file is not exist, then open call should create a file. But it do not create a file without a flag which we need to provide to this function. But the interesting thing that I want to show here is that you are not getting any kind of message here. You're just getting the another terminal to execute the next command. So no matter what I do, I'll be not getting any kind of error. So let's say it's a big program and it's there is some sort of an error, and your program is compiled successfully, and you don't know what exactly happened, and it's where the error handling comes into the picture. So now let us go to our Vim. I'll copy this entire thing. I'll escape this, and let us open our program IO ops error handling. So in this we will be doing an error handling. Let me copy whatever I have pasted, and that's a bad thing I did. Shouldn't have copied this.
File numbers. Now what I can do? Okay, let's do PQ. I'll fill up again. Higher ops. Now handling. Now I will be copying this whole thing. And let's go to the error handling function. I'll be doing this and back. I'll be doing this. Skip. Everything is gone. And let me paste here.
Nice and clean. Escape W. Now, in order to introduce the uh, error handler, I need one more header file here. I'll be doing this a lot. I'll be hash include error.h, which has a definition of our file. And since we are going to uh, throw an error or error message in this, we need to provide uh, some sort of input to the error function. So whenever the open system call is executed, what it returns the non-negative number when it is executed successfully. But when it is executed with error, it provides the output in the form of -1. So we will capture that output into the variable called as ft, and we will write a simple condition here. If ft is equal to -1, then what I need a p error, which will just print an error message, and that will be error associated with open. So the so this line number 10 should give us the what exactly happening and why our file is not getting created. So let's me save this file. Let me open a terminal. Let me just see what it is. Okay, so no file is created with the file we are intended to create. And let me execute this thing. It's an IO ops 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 error handle.c. I forget to give the name, but it will be a.out. So we got the a.out. Now it will still not be able to produce a file, but we will get some sort of an error here. Let's say here. Now we can get why we are not able to create a file, because it's say no such file or directory. So simple. There is no, we are trying to open file which do not exist. So let me remove this a.out and exit from here. So as I know the file do not exist, what I can do, I can just go to my open call and give one more flag here, which will tell my open call to, if file do not exist, you can create the file. And sorry, should be a create, no, without e. And let's see if this works. And we will be giving the name that will be error underscore handled. Okay, that's not occurred. Let's see, handled, what I'm doing. Okay, now let's see. Okay, so our program is executed and we have the new executable binary with error handled, and let's see what it gives. It executed successfully and we should have one text file here. And here we are, we got a new text file here. And with this we'll, so we got a file now, and let's clean up the directory. And I'm making some mistakes here. LT. So we have seen how an error can help into the identifying what exactly gone wrong. And now we will, as we have learned the basic operation, we will be now reading something from the file and writing to the file too. So for reading to the file from the file, let me create one file with some text. Hey, please read me, and this will be go to the read.txt. Okay, so now we have the one file read.txt. Let's see what is the content of the read.txt. Indeed, it's a content. Uh, Content is a little bit messy here. I don't know what happened. Okay, so read me. I did something wrong. And now say cat read me. With that bang sign, I'm actually uh, throwing with that bang sign, I'm actually pasting the previous commands. Wow, that's new for me. I didn't know that. I didn't know that. Honestly, I didn't know that. Oh, cool. I should check on this. Okay, we are not using the bang sign now. Okay, from this I understand. I come to know one important concept that I need to talk about: the universality of these I operations. As I mentioned in the slide, that these operations are not limited to the text file or general files only. So you can have these operations to in any kind of file. For example, in Linux, the terminal is also a file. So what we are going to do, we will be using the copy command, and we will be doing converting this terminal into uh, our small primitive notepad. Let me if this file is created, I will remove the read. I will remove the read.txt first, and now what I want to copy, whatever I'm writing on the terminal, should be copied into the read.txt, uh, and here it is. So hey, I am read.txt. Uh, please, please read me. Okay, so this thing, whatever I'm typing here, it's kind of a primitive notepad, and it should be copied into this file. So this is a very good demonstration of universality of these IO operations. To get out of it, you just need to press Ctrl C, and let's see what's written into the read.txt. Indeed, it's hey, I am read.txt, please read me. So thanks for that error. We covered this point also. So we will be exiting from this, and now we will be also exiting from this, and let me write or read IOPS IOPS read IO read. Okay, I'm sorry. IO read file.c, and here, as usual, I will be adding some headers. Include
file control.h this stat.h and include um, errors.h include stereo.h, and we will do one more thing.
will define a buffer here. Buffer size, max size, we'll say 200. Cool. That is the whole size. Like int main, as I said, it will be simple main, no argument taken, because we are reading the static files just for demonstration purposes. And here it is. Now let me open the file. It will be int ft is equal to open, and my file name is read.txt, and I want to open this file in a read write mode. Let's open in a read only mode, and here it is done. Now I will be uh, defining character buffer, uh, buffer with the name buffer, and sorry, and the size would be max underscore size. We forgot one crucial aspect of this thing, is that crucial aspect of this thing is handling an error. If I will put if ft if ft is equal to -1, I will say p error, um, open. That's done. I have a character size buffer, I have this, and now I will be calling to a size a size is size underscore t. This is just POSIX defined uh, data type, which we will be learning in future lectures. For time being, just be with me. I will say read num is equal to read. This will read. So read is the new system call, and we will the syntax to this system call is that we will be so the syntax of the read for system call is that we need to provide the file descriptor here, and then we will be providing the buffer name, and then this count of the buffer, that number of bytes to read. So here is ft, my buffer name is buffer, and count of the buffer is just size max size. Now, as usual, whenever an error will happen, the read num will be a -1. So let's add that error check. I will be like an error, and that would be error in the read. Okay, there is slight delay in my VM. Okay, so this is done. One more fundamental aspect that we forget to uh, address in previous videos is that we need to uh, close the files. So whenever we are opening a file, we should be closing the file. If we do not, it will not affect anyways to the program, but it's always a good practice to close the file, so that kernel and the system knows that file is no longer being used. Now return -1, say, and and uh, we do not just want to close the file. Let me close the file first, and we also want to know what is being read of in uh, from our buffer. So let's print it, and we will say the content of file read.txt is, I'll just do it will be a string, and it will be n. Let's say we can do this, and let's say again n, and this will be your buffer, and this w. Let's open the terminal and compile this file, gcc io read file. So I think we have compiled it successfully without an error. We just got some warnings about the fprint and that whole thing. Let's check it, and let's do. I'm not able to see, and okay, I think I should go on some another terminal. It's quite messy now. I will be doing ls and gcc. I will be io read. Let's see, hyphen o read file, and I have the one error at line 13. That's a semicolon I think I missed. So I'm going here and exit it. Uh, exit here. Okay, I missed the semicolon on line number 13. Let us go on line number 13 and enter. Okay, now to w, I will come here because everything is so much messy there. It's something else. I will be coming here. Read file. I think I should have read now. I will have the buffer. The buffer is undeclared. How it is undeclared? Characters buffer. Buffer is perfectly different declared here. So now I'm getting some another error. It is undefined reference to the printf fprint. Actually, it should be a printf. I'm just doing some stupid things. It's on line number 18. So let's go on 18. Let me check if it is recording. Yes, it's recording. Okay, line number 18, and I'm on 18. What's this? 18. I'm on 18, and it should be a printf rather than the fprint. That should remove this error. Let me clear the screen, and the error is gone. And we have the file read underscore file, and let us execute them. So the content of read.txt is, hey, I am read hey, I am read.txt, please read me. And then we have uh, this thing happening over here. Okay, so it's just a condition of some formatting. I have done some mistake on formatting, but still our purpose is done. We have successfully read a file read.txt using the function, because read.txt indeed has the content, hey, I am read.txt, please read me. And this is the read.txt, please read me. let us rename the read.txt's only to write.txt, and we will be now using the write function to do the write call on this file only. Let's say write.txt, and let me see, I have created write.txt file. For sake of simplicity, I will
be using most of the code from here, and we will just modify this code to write into the file because the video is already quite long. And let's go bin io just code write file. I will be testing this thing here. So everything is
correct. We have everything here. We have opened the file, but this file do not exist, so we need to rename the file. So let's go and rename this file to the write.txt, and now let's open the file in write only mode. We will be opening the file in write only mode, and if this is some sort of error, we will be getting error. The character buffer is this. uh, cool, and everything is here. I will be removing everything from here, and let me remove this. Let me remove this line too. Rest everything is okay, and let me create one string that I need to append, and let's call it str is equal to I have written this using write system call, and that's it. So now we will be again creating the one placeholder, one variable to uh, capture the uh, return back value of the write function, and it will be say the num write is equal to, I will be opening the write. Again, the write is a system call, and it is a syntax of, it will take the ft as your file descriptor as the first argument, then the buffer you want to write, and or the max size, whatever you want to write. And here it is. Now if num write is equal to -1, we need an error in write, and it should work. Now we don't need to print anything. We will be seeing this string appended the uh, on the file which we just read. Let me just do the w, save this file. I will be gcc io underscore write -o write file, and everything is cool here. lsfnlt, I go to write file, and here it is, write file. Let's execute it, and let's see the content of our write file, write.txt. So this is happening because mm, because we are taking uh, the buffer which is longer than the string. So you can, if you can see, this is the uh, your string that you want to write to the file, and the everything if you see here is a gibberish, which is just a random thing which is held by the buffer, and which whatever it is sending to the file, which is also getting printed out. And also one thing that you can notice, that the whatever content the file was holding, it's erased, and this new content was replaced. So we will be handling this thing in the future, future request. The way to handle it is that, to instead of the max size, I should be giving the size of this string here, and it will be, the first error will be gone. The second, for the second error, we need to use another another flag here, which is an append flag. uh, and we will be doing that in next lecture. So thanks for watching it. Please provide your comments. I will not ask you to subscribe or do likes, but yeah, do provide the comments, because that's what give me the feedback about the content, whatever I'm doing.